Welcome to AWS in Orbit. I'm your host, Maria Varmazis. And in this series, we examine the intersection of cloud, space, and AI technologies, focusing on their transformative impact and real human outcomes in sectors like environmental sustainability, critical infrastructure, and cybersecurity. We're exploring not just what's possible, but what's meaningful in the realm of space and cloud innovation. We grapple with the complex challenges and unparalleled opportunities that arise when we use space to address the pressing issues right here on Earth. And today I'll be speaking to Pierre Bertrand, co-founder and CEO of Skynopy. In this AWS in Orbit program, we're exploring how AWS for Aerospace and Satellite enhances Skynopy's ground station as a service mission. Here's Pierre with more details about how Skynopy got started.
We founded Skynopy a year ago by noticing that in the market, the current space market and space industry has been if we think it's based on three pillars. The first pillar is basically the launchers, the rockets that you use to send satellites into orbit or systems, orbital systems and other capsules or stations. The second pillar is basically the satellites in itself, the hardware, these systems that are going to live in orbit and sustain and needs to be efficient and to be operational in orbit. And the third pillar that is less known and less advertised and less visible, I would say, it's the ground station. So it's basically antenna that you rely on to download the data created into orbit, but also that you use this ground antenna to talk to your satellite to send commands and receive what we call the telemetry, so the data. And the space market is booming because the two first pillars have been completely disrupted over the past 15 years, mostly by SpaceX, but also by other players. And the third pillar hasn't really changed for the past 60 years. So it's same type of antenna that we're relying on. And so now it's starting to be the bottleneck. And if we zoom in a little bit more, we see that satellite operators are facing two major difficulties and pain points. The first one is the need for CapEx to invest in their ground antenna, as well as investing in their launcher capabilities and their satellites. So it's very tough for newcomers into the market to buy their 10, maybe 20 satellites, and as well buy their 10, 20, maybe 30 ground stations. So this market does not scale if all of these new operators need to buy their own antenna. So we see that it's a market where if we take the analogy of the cloud, something can be done. The second pain point that the market is facing is that if we take the analogy of the mobile phone connectivity, these days you have operators that can sell antenna time, but they are not, it's as if T-Mobile or AT&T or Vodafone or others were just providing you a map of the location of their antenna, but not providing you any SIM card. And as we see that this is not scalable. The market is as if you to use your phone, you needed to basically know which frequency modulation protocols use to just send a WhatsApp and to point your phone towards the nearby antenna, and so knowing where they are and so on. So this does not scale. And what we want to do at Skynopy is basically solve these two issues. So the need of CapEx, and we solve it by providing a network of ground station, and we sell antenna time, antenna access, rather than just selling the antenna. And the second thing that we are solving is basically this lack of end-to-end connectivity. So it's providing our customers basically the connectivity kit to put on board of its satellites to natively be connected to ground stations.
First of all, it's fascinating to hear how you're disrupting just the ground station access market. That is fascinating on its own. And then also you're talking about sort of a really interesting differentiation between, ground station access, that's a very basic thing, and a connectivity as a service, which is a whole new paradigm. Can you tell me a bit more about that paradigm that you're developing and maybe what that looks like also for your customers?
Yeah. So the end goal, we believe that all of the new customers coming into orbit these days, back in the days, they had like experts in launchers of satellites, of radiation, of thermal engineering, of software, and as well of radio frequency. So antennas, modems, radios. We see that as the market evolves, you no longer need, when you launch satellites, to have an expert of launchers because SpaceX is taking all of that for you, all of that expertise. And our dream is basically to have in the future, when you launch a satellite or a constellation or other stuff, you don't need any radio frequency expert because we're going to provide to you the end-to-end connectivity. And we believe that when you launch a satellite or a constellation, you want to focus on your end customers. So if you take images of the Earth in hyperspectral or infrared or stuff, you want to know exactly what your end customer wants. So firemen detecting fires or detecting I don't know, illegal fishing. If you launch a debris removal, you want to have AI and computer vision and cameras on board of your satellites to take debris and remove them. And all of these applications you don't want and you don't need necessarily with the Skynopy offer. The radio frequency engineers and to handle all of the complexity. So it's kind of back in the analogy of the mobile phone connectivity. And so this is our vision for the market. We're not there yet, but our value proposition is basically to offer this ground network of antenna that is highly scalable. So within just 10 months, we already succeed to access 15 antenna all over the world. That is well enough to secure 2 passes per orbit for satellites, which is more than the current state of the art of the market. And the second thing that we're providing, so it's not only the ground network, but it's this end-to-end connectivity. And this is thanks to our connectivity kits that we're developing.
That's fantastic. And that is and considering your company is still very new, that's an amazing vision to have. I feel like this is probably a good time to also introduce your partnership with AWS. Can you tell me a bit about how working with them has accelerated your go-to-market strategy?
Yeah. So we did see how complementary was the approach with AWS, and we're extremely happy with this partnership for several reasons. We saw that AWS is seeking businesses where they can scale very, very strongly across hundreds of thousands of maybe millions users. And when we zoom in the space business and satellite business, we do see that you always have very tiny discrepancies among customers, and it does not scale super well. And so we see how complementary we are with AWS because we take over AWS on this part because we know well the market and we have this radio frequency expertise that is the kind of the last mile towards the end customers that we can take over. And so it's really complementary because we're relying on this huge network of 12 ground stations all over the world that is extremely beneficial and that would have taken years to build and operate. But we're adding this parts of engineering and business intelligence and business knowledge that AWS did not want necessarily to invest in. And for us, I think it's 3 good news for us because it gives us access to a large amount of stations of antenna very soon in our history. All of the process of the technical review by AWS engineers was extremely beneficial for us to grow in maturity very fast. And it's also a trust that AWS is providing to us in terms of commercial pipeline and differentiator compared to our competition.
I would imagine, given what AWS does, cloud also plays in here a little bit as well, a lot. Can you tell me a bit more about that also?
Yeah, so working with AWS, it's extremely beneficial because of the stations for the business we have. So they have also like large ground antenna, so 5.4 meters antenna, which is like above the standard of the market. And then it's not only the antenna, but it's all of the cloud suite that we can use that scales very well, and that's extremely mature technology to handle. And so basically, it's very easy for us to, based on this infrastructure, to focus on like the difficulty of like handling radio frequency, modems, radio, and like adding this to our customers.
Fantastic. You have a lot of different types of customers, I would imagine. Tell me about them.
This first type of customers that we're selling to are what we call satellite operators. So they're basically like players that needs to connect their satellites to retrieve the data from orbit and like talk to their satellites. Among this first category of satellite operators, we would say there are like three types of players. The first ones are Earth observation satellite operators. So using their satellites to take pictures of the Earth to serve customers being in agriculture, in environment, in defense, in like a whole bunch of like markets. The second subcategory of satellite operators are more like connectivity and IoT, Internet of Things, or RF, or like telecommunications constellation and operators who wants to send their satellites to help people on the Earth to better connect to objects, to other people, and so on. So there's the second subcategory, and the third category of subcategory of satellite operators are all of the operators that want to operate services in orbit. So basically, like docking with other satellites, debris removal, space manufacturing, all of these. So this is a big first category of people who want our ground station or the ground station we can leverage to operate their satellites or constellation, so being multiple satellites. The second category of customers that we help, we call them like satellite platform providers. So it's basically the manufacturers of the satellites on the ground that sell the equipment, the hardware. And we see that the market these days is like we have these players that are specialized into this hardware, but when it comes to connectivity, to how like to choose the right antenna on board of the satellites to connect to antenna on the ground, they are usually sub-optimized. So we can go to seek them and help them to maximize their data rate, or what we call the data budget. So it's the second type of customers that when we do see like that we bring a significant gain and like added value for these customers.
Absolutely. It sounds like what you're doing is really a force multiplier and also just an optimizer. I'm using a lot of computer terms, but it makes a lot of sense given what the market needs and also where you all fit in. So it's just really fascinating to see what you're doing. When you think about the convergence of technologies in space, cloud, and connectivity, as we've been talking about, what opportunities do you see there? I mean, especially where Skynopy fits in. There's got to be a lot there that you see really ample opportunity.
Yeah, so we see like a rising need for doing like edge computing in space. So like you take pictures, but like it's still like very long and very costly to download all of the picture on Earth. And sometimes for some application, you need to treat the data on board of the satellites. We're not there yet because when you fly hardware in orbit, it needs to be resistant to radiation, to thermal temperature, and so on. And we don't have so much of GPU, for example, over there. But we see that as we go, there are more and more applications and more hardware to be being developed to basically maximize the edge computing part and to do processing on board. This is very interesting for us because potentially you will download less data at like T0, but most of the time we see that T0 you will download less data, but like maybe when you have time you will still download the entire picture. And in any case, we see that this Internet of Things and edge computing paradigm are always requiring more connectivity than less connectivity. Even though you treat data on the edge, it requires like more frequent feedback loop, basically.
And that's it for AWS in Orbit, Ground Stations as a Service with Skynopy. A special thanks to Pierre Bertrand for joining us today. And for more resources from this episode, and for more episodes in the AWS in Orbit series, check out our show notes at space.n2k.com/AWS. This episode was produced by Alice Caruth and powered by AWS. Our AWS producer is Lara Barber. Mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our associate producer is Liz Stokes. Our executive producer is Jennifer Iben. Our executive editor is Brandon Karpf. Simone Petrella is our president. Peter Kilpie is our publisher. And I am your host, Maria Varmazis. Thanks for listening.